So let's get into what exactly the isotope of something is. We already discussed this a little bit, so we don't need to linger on this too long. But an isotope is a version of an element, the same element with the same number of protons, but a different number of neutrons. So the number used to express a specific isotope is the amount of nucleons, which is just nucleus particles. Nucleons is a category, not its own particle.
Oh, okay. I was going to say, I'd never heard of that, but that makes sense.
Yeah, nucleons are just a category of nucleus particles. So when we talk about last episode, we said xenon-135 a lot. That got thrown all over the place. So xenon-135 is equal to 135 nucleons, which is just particles in the nucleus, which is the same as 54 protons plus 81 neutrons. So, but we know that xenon-135 is radioactive. It's not stable. It will decay in about 9.2 hours.
Right.
So 54 protons plus 81 neutrons is not a stable combination of protons and neutrons. All right. So now these radioactive decays can get crazy. So as we just said, xenon-135 will decay into cesium-135. It undergoes beta decay. So beta decay was this would be beta minus decay. A proton turns into a neutron and emits an electron and an antineutrino. So because a proton goes away, the element changes.
Right.
And a neutron gets added to the nucleus. So xenon-135 can go into cesium-135. The number would stay the same, but
because it's the same amount of
nucleons.
Nucleons, that's the
exactly.
word. Yeah.
But there's one less proton, so it turns into cesium. So when the xenon-135 beta decays, it changes its element. Now, like I said, these radioactive decays can get crazy when something of a lot of nucleons decays into something that is still unstable. That decays into something that is still unstable, and so on. So uranium-238 is one of these very isotopes. Uranium-238 can undergo 14 decays before it turns into lead-206. And it takes a while. So uranium-238 is technically radioactive. So it's not safe technically, but its half-life is 4.5 billion years.
Jeez.
So uranium-238 takes a while. And when it decays into thorium-234 because it undergoes an alpha decay. It emits 2 protons and 2 neutrons. So U-238 goes into thorium-234. Thorium-234 is still radioactive. It undergoes a beta decay into protactinium. God, that was a tough one. Protactinium-234. That decays in about 6.7 hours. Protactinium-234 decays into back to uranium.
Oh.
It turns back into uranium-234.
Oh, okay.
So uranium kills itself, turns into something else, which kills itself, and then it turns back into uranium. Given enough time, uranium will change and then go back to uranium. That's freaking crazy, first of all.
Yeah.
That an element can just turn into something else and then it just turns back into its thing again. That's wild. So, but it's still radioactive. So that uranium-234 decays into thorium-230 after about 250,000 years.
Okay, yeah.
That decays into radium-226 after about 76,000 years. That decays into radon-222, which decays into polonium-218, which decays into lead-214. We're at lead, but we're going away from lead because that's a radioactive isotope of lead. Very radioactive, mind you, because that decays in about 3 minutes. So that decays into bismuth sounds right. Bismuth-214. That decays in about 20 minutes to polonium-214, which decays in about 20 minutes to lead-210. We're back at lead again.
Not very long.
Not for very long. After about 164 microseconds, that decays back into bismuth. We're back to bismuth, baby. And it stays that for about 20 years.
Yeah.
Nice and long. Stays bismuth for about 22 years. But that decays into polonium. We're back to polonium-210. That decays in about 5 days. And then we're back to lead-206, which is stable. That's insane.
Wow. And it's funny how different these time frames are, because like you'll get thousands and thousands and thousands of years, and then it's like 20 minutes.
Exactly. Yeah. The uranium-238 stays 238 for 4.5 billion years, and then the freaking what was it? Yeah. Bismuth-214, or excuse me, polonium-214 decays into lead-210 in 164 microseconds.
Yeah.
Like, and we get uranium turning out of uranium back into uranium. We get polonium going away from polonium, turning back into polonium, and then going away from polonium and turning back into polonium again. Lead, polonium turns into lead, which goes away, but it comes back for 164 for 22 years, and then it goes away again, and it comes back as stable.
Yeah.
Like, this is insane. This is literally like Legos jumping off of each other and collecting. Like, this is nuts. This is nuts that our world can do this, where things can just turn into other things and then back to the same thing with a different amount of neutrons and protons. Not protons, different amount of neutrons. Crazy. So radioactivity is insane. And it's dangerous. Sometimes. Not always. It depends on which one we're talking about.